math people, our next geometry lesson, two-dimensional geometry that is. So we've done a quick recap of squares and rectangles as a pre-lesson for this chapter. Your first shape was parallelograms, and now we're moving on to our next shape. So without further ado, we're going to be talking today about triangles, how to find the area of triangles. I'm going to start off by just giving you the formula straight up, and then we'll talk a little bit about some of the parts of that formula. So to find the area of a triangle, any triangle, whether it's like this green one, a right triangle, whether it's like this reddish one, doesn't matter. Any triangle, the formula is area is base times height times 1/2. Now, you'll see this formula written a variety of ways. Some people will write it, just so that you're familiar with what it looks like on paper, some people will write the formula as area equals 1/2 BH. That just means 1/2 times the base times the height. Other people will write this formula, area equals base times height divided by 2. When you divide something by 2, it's the same as multiplying it by 1/2. So it's personal preference. It doesn't matter to me which version of the formula you use, whatever feels more comfortable. If you want to multiply the base and the height and then multiply by 1/2, or if you want to multiply the base and the height and divide by 2, it doesn't matter to me. Now, really quickly, where does that formula come from? Like, why the heck are we doing b times h times 1/2 or dividing by 2? Similar to parallelograms, the formulas all come from other shapes, or you can connect them back to other shapes. So let's take a rectangle, or this kind of looks like a square, but how do I find the area of a rectangle or a square? I do length times width. Now, what could I do to this rectangle in order to turn it into a triangle? Well, one thing you could do is you could cut the thing in half. And if you cut this in half, what you've just formed is a triangle. Actually, you've formed two triangles. One's right here, and one is right here. Now, if the formula for a rectangle was length times width, what would be the area of just one of these triangles? Well, it would be length times width, but since the triangle, the red one, for example, only takes up half of the space of the rectangle, we would then take the length and the width and we would divide it by 2. We would cut it in half. So that's where the formula base times height divided by 2 comes from. We're just using different words. Instead of length and width, we're using base and height because those are terms that we use to describe a triangle. And the reason we're dividing it by 2 or multiplying it by 1/2 is because a triangle is half of a rectangle or a square. So anyways, those are the formulas that you can use. Pick your poison, doesn't matter to me. And before we do any actual computations, let's also quickly talk about what is the base and what is the height in a triangle. So on a triangle, any of the three sides can be called the base. What matters is where is the height in the triangle? So the first thing you should actually look for when you're just deciding what's the base is you should actually first find the height. And the height, by definition, is the straight distance that goes from the base, whatever side the base is, to the furthest point across from the base. For example, it's easier to understand things, I think, visually. Those words are a little confusing. If I had, in this red triangle, a line that goes from this side all the way straight up to the furthest point across from it, this would be defined as the height. Because the height is any straight distance that goes from one side straight across to the tallest point of the other side. So in this red triangle, this dotted line could be the height. Let's take this same triangle and look at it a different way. What if I had a straight line that goes from here to here, from this side straight across to this side? Then this would be the height. Similarly, let's do it one more time. Oops. What if I had this same triangle, but I had a line going from this side across? Then this would be the height. Now, depending on where the height is, that will tell you the base. The height runs from the base straight across to the other side. So if I was presented with this triangle with a straight line going across here, then the base would be here and the height would be here. In this triangle, this would be the base, because the base and the height goes from the base across. In this triangle, this would be the base. Going from here all the way across would be the height. Sounds a little confusing, but once we start doing some examples and you see some triangles with numbers drawn in, I think it'll make a little more sense. Lastly, in a right triangle, if this is the base, then the height is actually this other side, because it's a straight measure that goes from this base all the way up to the height, the tallest point across from it. So right triangles can be a little unique because the height is one of the sides sometimes. Like if I'm given this as the base, then the height would be going straight up and down from the base to the tallest point across from the base. But let's look at some examples. I think it might help you to understand what I'm saying about base and height. Here I've got that exact green triangle from up above in the notes, and the area of any triangle is base times height divided by 2. So with that in mind, the base is this side, the height is this side. Because it runs from the base to the tallest point, I should actually have a right angle symbol in there so that we know it's a straight line, but this would be the base and the height, and so therefore the area would be 20. Now, always remember your units. Since we're dealing with inches, that would be inches squared. 20 inches squared. Base times height divided by 2. Or base times height times 1/2. You're going to get to 20 inches squared either way. Let's give you a shot on one. We've got this red-looking triangle. We've got some measures defined in there. 3 questions for you. What's the base? What's the height? And overall, what is the area of this figure? So it looks a little bit funky possibly, but the base, I'm going to say, is 12. And the reason I'm saying that is because the value of the height in this goes from the base straight up to the tallest point of the triangle. Now, in this one, instead of drawing the height directly through the middle of the triangle, I drew it on the side of the triangle, but that doesn't change the fact that it's the height. It's the distance from the bottom all the way to the tippy top. That's the height. So area equals base times height divided by 2, or base times height times 1/2, whatever formula you want to use. So 12 times 9, cut it in half. I'm not going to show all the steps there, but that would be 54 as a final answer. 54 feet squared. There you go. All right, hopefully you got that one, but if not, I've got one more opportunity for you. I don't know if you've ever heard of this place or this phenomenon, but there's a spot called the Bermuda Triangle. And I've got it outlined here on this map. I've used some black dots to clearly show you the 3, Miami to San Juan to Bermuda. When you triangulate those 3 locations, this spot is known as the Bermuda Triangle. In theory, a lot of ships or people or things get lost when they're in that area of the ocean. Anyways, my question is, how much space does the Bermuda Triangle take up in this part of the ocean? And In other words, I didn't say the word area, but what's the area of the Bermuda Triangle? How much space does it take up? So I'll give you a second to compute how many square miles the Bermuda Triangle takes up, and we'll see if you got it. So I got area equals base times height divided by 2. So the base is 1,000 miles, and that's the distance from Miami to San Juan. The height is the straight distance from the base all the way up to the tippy top of the triangle, which in this case happens to be Bermuda. So that's 900 miles. And it's that whole product divided by 2. So 1,000 times 900 is 900,000. Divided by 2 is 450,000 square miles. So the Bermuda Triangle takes up 450,000 square miles of space in the Atlantic Ocean, just off the coast of Florida. Anyways, this quick video outlined how to find the area of a triangle, the formula, where the formula came from, and a couple examples. If you've got questions, feel free to let me know. Otherwise, do your best to get some notes written down, and we'll go over this more in class and practice the skill and build on it with some extra triangle bonus content tomorrow. See you then.